Two protons approach each other. The protons have been accelerated to very high energy, practically the speed of light. Let's zoom in on one of the protons. It is composed of three quarks, two up quarks and one down quark, moving around very close to each other. The quarks are kept together by a number of gluons interacting with the quarks and also with the other gluons. The gluons give rise to the gluon field that keeps the constituents of the proton together. When the two colliding protons get very close or overlap, the proton interaction is due to two gluons emitted from one quark in each of the two approaching protons. The two gluons merge in a very high energy interaction, producing a massive top and anti-top quark. Let us start by following the top quark. It will start a complicated sequence of decays into less massive quarks. The top quark decays into a B quark and a W particle. The W particle is the mediator of the weak interaction and can decay in several ways. Here, the W decays into a U and an anti-D quark. These quarks will combine to give rise to detectable particles, but we will focus on the more massive B quark. The B quark decays into a C quark and a W, and the W decays into an electron and a neutrino. The C quark then decays into an S quark and a W, and the W decays into a U and an anti-D quark. Finally, the S quark decays into a U quark and a W, followed by the W decay into a D and an anti-U quark. The complex decay sequence from the massive top quark to B, to C, to S, and to U quarks is all governed by weak interaction mediated by the W particle. The decay sequence initiated by the top quark involves all the known quarks. Let's also follow the decay sequence of the anti-top quark. It is very similar to the top quark decay, but with the antiparticles. The anti-top quark decays into an anti-B quark and a W particle. The W particle can decay in several ways. Here, the W decays into a D and an anti-U quark. We will follow the more massive anti-B quark. The anti-B quark decays into an anti-C quark and a W. And the W decays into a positron, the antiparticle of the electron, and a neutrino. The anti-C quark decays into an anti-S quark and a W, followed by the W decay into a D and an anti-U quark. Finally, the anti-S quark decays into an anti-U quark and a W, followed by the W decay into a U and an anti-D quark. Zooming out, we see all the numerous particles produced by the decay of the top and the anti-top quarks, which will be detected in the ATLAS detector.